Hello everyone, this is Group 5 and here are 白嘉欣、石磊磊、邱明慧、潇潇 and Wang Junling. Today our presentation topic is about SVB case study, AL and machine learning. And here are our contents. First comes to the introduction. Actually, our main character of this case, SVB, is a cornerstone of the United States banking sector, especially referred within the technology and startup investment realms. In 2023, they just faced a really severe and an unprecedented liquidity crisis, culminating in its downfall. This event not only became the third largest bank failure in U.S. history, but also stood out as the most significant banking collapse since the biggest 2007 financial crisis, occurring in tandem with the failures of Signature Bank and Silvergate Bank. So after we have the deep study of the causes of this case, we just find the three really closely related causes. The first one is the SVB's investment strategy issues. Actually, the SVB just have a lot of the long-term securities in its portfolio, as this just plants the fuels to the second cause. When the rising interest rates occurs, this long-term securities just have a fiercely increased interest, and it will result in the increased borrowing costs, which the SVB can't hold at a really short time. And at the same time, the clients also face the same situation. They also have some borrowings, and some of them also have the long-term securities. So they will also face the increased interest. So in order to cover these escalating expenses, the clients also should withdraw their deposit from the SVB. So these two causes I stated before just lead to the final cause, the liquidity crisis. In order to persist for longer time and to face this difficulty, they can only offload the securities and loss and secure the borrowings. This will lead to the really high deficits. And when this kind of the financial situation and this news spreads really widely among the clients, this will create really high scared moods among the clients, and that's why it finally triggered a massive back run. And this is the final straw which can break the whole SVB. So let us see how the government responds to this kind of the difficulty. Firstly, the government just choose to protect the interests of the clients. The FDIC just assure that all the depositors will regain access to their funds. Secondly, the FDIC just choose to restructure the SVB, which just faced the crisis of the bankruptcy. The FDIC's strategy involved the temporary operation of SVB under a new entity, with the intention of the auctioning the bank's assets or finding a buyer for the bank as a whole. So actually, the fallout from the SVB's collapse was far-reaching. Just as what I stated when in the introduction, SVB is a really big bank, and it has a lot of the big clients, just like the startups, enterprises, and the multinational tech giants. Just because the SVB faces this kind of the problems, all the stakeholders just cannot escape. They will impact severely, and to lead to the decreased financial trends of the whole society. So it's really severe. Among all these stakeholders, many of which is to find themselves cannot access to their operational funds overnight. What's a really ridiculous situation. So this incident served as a stark reminder of the systemic risks posed by the concentrated bank's relationship with the specific industry sectors. So after really simple introduction, secondly, we will come to the problem statement and solution. So to summarize the problems we just stated before, it can be divided into two parts: the macro and the macro and the micro problems. For the micro problems, these problems just cannot avoid because it just be decided by the market conditions, just like the rapid rise in the interest rates, and also for the really loose regulatory landscape. They can all become the causes to why the SVB just face this kind of the collapse. But from the macro to micro, why the SVB becomes the biggest victims to this kind of the market conditions? That because their aggressive investment strategy. They just have a lot of the long-term securities, and they also have don't have the really good risk control. And also, as the macro problems, so human factors also should also deserve us to focus on. When the bank not operate really well, the rapid and widespread withdrawals will happen. So, we should really think about these problems and find the solutions to solve it. And also, for the clients, the individual clients of the SVB, just because they just don't have the sufficient hedging against the interest rate risks, so they can become the victims in this case, as they just impacted by the problems of the SVB. So how to solve these problems? For the market conditions, just as I said before, we can't avoid it, but we can predict it. So we just think about to use the AI and machine learning to create the crisis prediction and risk management model, and the fraud detection and compliance model to solve the market conditions problems. And for the micro problems, just for the company specific issues, we also think to create the market monitoring and the investment decisions model to help the bank to better have the risk control and to choose their investment strategy. And in order to increase their operational speed and to face the specific obstacles faced in this big event, we can also create the operational efficiency and customer support to help the banks to go through this crisis. And for the human factors, in order to decrease the spread of the scared moods, we can find the special statement analysis and market perception.
Then let's come to the models and results part. And first, we come to the financial crisis prediction and investment decision insights. And this analysis objective is to help financial institutions to predict financial crisis precisely, and it can help them in smoothly navigating through financial crisis, and also can get some more correct information about investment decisions. And the data set we use is the cargo data set, and these are the variables. And the banking crisis is the Y variables that we need to predict. And first, we do some data exploration like descriptive statistics and also correlation analysis to get initial insights of the data. And then we use logistic regression, random forest, SVC, KNN, and decision tree to model the data. And we can find in this prediction, SVC is the highest accurate model, and followed by random forest. And by making this analysis, like the crisis prediction, it is really helpful for financial institutions. First, it can help financial institutions earlier identify the risks about some financial crisis. And second, it can enhance financial institutions' market reputation, like attracting more investors and to improve its competitive market position. And thirdly, it can optimize financial institutions' asset allocation. And besides, for getting more correct investment decision insights, AI can also help financial institutions develop AI-driven risk management strategies. And secondly, they also can help financial institutions get real-time monitoring of market conditions and assets price to further their investment decision insights.
In addition, there is an increased likelihood of customers engaging in potentially fraudulent transactions in financial downturn. Therefore, in this scenario, we would like to employ AI to detect fraudulent transactions to mitigate financial losses and protect operations for banks. We obtain the data from Kaggle, where it contains 284,807 credit card transactions, of which the variables are time, seconds elapsed between each transaction and the first transaction, amount, which is the transaction amount, class of 0 indicating normal transaction and 1 indicating the fraudulent transactions. And there are 28 PCA transformed features due to the confidentiality issues. By exploring the data, we can see that the dependent variable class, majority of the transactions are normal. That is only 492 are fraudulent transactions, meaning that the original data set is highly imbalanced, which also reflects the true scenario in the bank. Moreover, looking at the correlation matrix, V1 to V28 PC components are not correlated to each other, thus low probability of multicollinearity. Here, we create 4 machine learning models, namely logistic regression, random forest, XGBoost, and neural network for this classification problem. All models perform well with more than 90% in all 3 parameters: accuracy, precision, and recall. In this case, true positive indicates correctly identifying a fraudulent transaction. False positives occur when normal transactions are mistakenly flagged as fraudulent, potentially inconveniencing customers, while false negatives denote failure to detect fraudulent transactions, posing risks to customers. Apart from accuracy, precision and recall may put more priorities in this case, as we want to prevent the risk of mistakenly classify any fraudulent transactions. Therefore, random forest seems to yield the best result. In the case of fraud detection, we believe that AI can play a pivotal role. It can analyze patterns and anomalies in transaction data in real time, enabling early detection of potentially fraudulent activities. These models can continuously learn from the new data and adapt to evolving fraud tactics, making them highly effective in detecting sophisticated fraudulent schemes. Banks can thus take immediate action to prevent financial losses. Moreover, AI-powered credit risk assessment models can analyze diverse sources of data, including transaction history, credit scores, and socioeconomic indicators, to evaluate the creditworthiness of borrowers more accurately. By leveraging advanced tactics, banks can make informed lending decisions and minimize the risk of default. During economic downturns, the risk of non-performing assets increases as borrowers may struggle to repay their loans. AI can help banks proactively identify borrowers at risk of default and implement targeted strategies to mitigate losses. Overall, AI-driven fraud detection and risk management solutions enable banks to protect their customers' assets while minimizing disruptions to their banking experience. By leveraging advanced technologies such as machine learning and natural language processing, banks can streamline fraud investigations, reduce false positives, and enhance the overall customer experience.
To address the challenges during the financial crisis, we plan to adopt AI-based tools for automation and customer support. We selected UiPath for automation and Snatchbot for chatbot development. We conducted testing to ensure the accuracy and reliability of them. For operation efficiency, we have created a robotic process automation, which called AutoBank, that can be applied to deal with the issues. It can automate repetitive and rule-based tasks in banking operations, such as data entry, transaction processing, and report generation, such as processing deposit, withdrawal data, customer information data, financial data, and so on. Any banking data in Google Sheet can be automatically and quickly written into the Google form through this process without any human operation. To save processing time for banks and financial personnel for customer support, we have designed a bank customer service robot. It's called Silicon Bot. It can take over almost all the pre-service and inquiry business of service personnel and provide customers with information they want at a very fast speed. Let's imagine a scenario where banks and financial institutions are overcrowded during any financial crisis, with many customers queuing up. One customer needs to check their personal banking page and select like an investment portfolio that suits their risk preferences. In the past, the customer had to walk to the physical bank and wait in line for a long time, resulting in a poor service experience. Additionally, the difficulty of obtaining financial services for the customer increased, which to some extent led to the occurrence of various problems mentioned in the case. After having this type of robot, customers only need to use Telegram online at home to input personal information and select or input the questions they want to consult. According to the program design, the robot will quickly respond accordingly. Let's talk about advantages of RPA AutoBank. UiPath automation streamlines internal processes and tasks checked in Google Sheets, improving work efficiency and collaboration through automatic updates and notifications. It also enhances convenience and efficiency for bank staff. Banks can properly understand customer feedback from Google Forms, facilitating timely improvements. And for advantages of Silicon Bot, offering services round the clock, Silicon Bot provides immediate assistance in the emergencies, enhancing customers' satisfaction and loyalty. Integration across various platforms enables engagement with customers on preferred channels.
In the landscape of finance, understanding market sentiment is as critical as the numbers themselves. To deploy advanced NLP and LSTM techniques to analyze the sentiments of financial news, with over 4,845 entries analyzed, we are translating the complexities of market language into actionable insights, aiding institutions to navigate the nuanced waters of investment with a data-driven campus. Data pre-processing included steps such as removing HTML tags, converting to lowercase, and removing spatial characters to ensure that the data quality was suitable for subsequent model training.
Initial exploration of the data revealed an uneven distribution of sentiment in financial news headlines, with the majority of the news being neutral, followed by positive and a relatively small number of negative news. This distribution reflects the emotional tendencies of the financial news in the real world and shows the diversity and complexity of emotional expressions in financial news headlines. In order to classify sentiment from financial news, the project uses the dog-to-vex model to convert the text into the vector representation and then utilizes a long short-term memory network to process the sequence dependencies in the text for the sentiment classification. This combined approach aims to improve the accuracy of classifying the emotional tendencies of financial news headlines. The key steps in model construction are model initialization, embedding layer, LSTM layer, and output layer. We train the model with the training data and use the test data to evaluate the performance of the model. The model achieved 99% accuracy, but the performance on the test set dropped to 69%, which may indicate that the model was overfitted on the training set. The results of the confusion matrix indicate that although the model predicts relative accurately on the neutral category, it has some challenges in distinguishing between positive and negative emotion. The application of machine learning techniques in sentiment analysis of financial news presents an innovative approach to understanding market perception. The discussion below outline the significance and potential implications of these techniques. The first is enhanced perception of market sentiment. Our LSTM model provides a layered understanding of market sentiment, enabling institutions to finely tune into the pulse of investor emotions and emerging market trends. The second is predictive insights for market movements. Leveraging sentiment analysis as a predictive tool, our ML framework offers early indicators of market shifts, empowering traders to strategically position themselves ahead of the curve. The third is machine learning model refinement. Despite its high training accuracy, our LSTM model's performance deep on unseen data highlights the need for continuous refinement and validation to ensure robustness and reliability. The fourth is limitations and ethic considerations. While promotion, the model's potential biases and the ethical implications of automated sentiment-based decision-making underscore the importance of transparent and responsible AI deployment in finance.
Hi, let's come to the conclusions. The analysis of SVB's collapse underscores the significance of AI and machine learning in navigating financial systems during crisis. We involved 4 machine learning models. The first one is financial crisis prediction model. We utilized 5 algorithms to predict bank crisis using historical data from 13 African countries. SVM model demonstrated the highest accuracy of 98%, showcasing it can handle complex business scenarios. The second one is fraud detection model. 4 algorithms were employed to detect abnormal transactions in credit card data. The random forest model achieved a record rate of 97%, highlighting the robustness of ensemble learning algorithms in addressing imbalanced datasets. And the third one is RPA and customer service chatbots. Through UiPath, for RPA and dashboard for chatbots. We automated core banking processes and developed intelligent Q&A capabilities. This automation significantly enhanced operational efficiency and customer experience, particularly during financial uncertainties. And the last one is sentiment analysis model. We analyzed real-time sentiment trends in financial news headlines to market sentiment. Although the model's generalization capability requires improvement, it showcased the potential of sentiment analysis in guiding investment decisions. And these results underscore AI and machine learning's potential in addressing internal and external risks for financial institutions, enhancing decision efficiency, controlling cost, and managing market sentiments. But their application also presents challenges, like handling sensitive data requires robust security measures to prevent breaches, like a clear regulatory framework is necessary to address compliance risks, and excessive reliance on AI may increase vulnerability to technical failures and attacks. Public concerns about AI's impact on decision-making and fairness require transparency and trust-building efforts. So balancing technological innovation with ethical consideration and society welfare is essential for AI's sustainable integration into finance, so that we can ensure an equitable future for AI in the financial sector. Thank you very much.